Hi, now let's look at Lami's theorem. Suppose you have three coplanar concurrent forces acting at a point B in equilibrium, then each force is proportional to the sine of the angle between the other two. So now let's look at the meaning of it. Okay, so you have three concurrent forces acting, and the concurrent forces should be always acting outwards. Suppose if it is acting inwards, you need to convert that and make it in such a way that it is the forces are acting away outwards from one point. So let's look at this. So this is force F1 and this is your alpha. F2, this is your beta. If you do like that, it will be easy. And F3 and F3 is equal to gamma. So these are your three angles. So let's write the theorem and I'll show you how it will look. Um, so F1 divided by sine, and what is the opposite? We need to check the opposite angle. So this is your F1 and the angle between F3 and F2, which is alpha. So you have to write alpha here is equal to F2 divided by you need to look at F2. This is your F2 and it is coming here, and the other two forces are F1 and F3 and the angle between that is beta. So sine beta is equal to F3 divided by sine of we need to check the F3 and the other two forces are F2 and F1, opposite side of forces to F3, and this is your angle between that forces, and that is gamma. So gamma. So this is how the Lami's theorem is written, and now we'll look. Suppose if you have a force which is acting inwards, what you should do. So let's look at that. So this is our Lami's theorem. So now let's see how we will deal with a force which is acting inwards. So let's see. This one is force F, say F1. This is your F2, F2, and say this is your force acting inwards, which is F3. Okay, this has to be dealt like this. So you need to draw the F1, you need to draw the F2, and F3 should be parallel to this. This force should be drawn here at same magnitude and same angle. So this is your F3, and say you can draw, the line should be, yeah, okay, this was your original F3 and it should be drawn like this, and then you can do the math in that. Say so F1 opposite to that, this is alpha, F2 opposite to that, this beta, and F3 opposite to that, this gamma. And now you can do the with the Lami's theorem you can do the problem. Okay, now let's look at equations of equilibrium. Suppose you have this three concurrent forces again, which is acting, say, outwards, okay, or maybe one if it is inwards also, no problem. We have already studied how to take the components of each forces, and you can also solve that with equations of equilibrium. Equations of equilibrium is nothing but we'll do one assumption in that. In that we will do is sigma h, and we have studied, it could be sigma h or sigma fx, or say in sigma rx, depends on the book you are using. We take it as 0, which is the horizontal component. The summation of the horizontal component is taken as 0, and the summation of vertical sigma fy, and or it could be sigma ry is equal to 0. This should be 0 separately. Then only the condition of equilibrium will meet. Okay, so this is one way of having Once we put this to 0, we can solve the components, we can add up the components and equate that to 0, and we can solve the problem. Now let's look at a few problems, or maybe just one problem, and see how that is done with the help of Lami's theorem, as well as with the help of equations of equilibrium. Okay, with Lami's theorem, you will have to convert if there is any force acting inwards. But in equations of, if you are using equations of equilibrium, you really don't need to convert those equations. So what you can do is you can go on doing the problem by taking the components, and you just have to give the correct respective signs, okay, for equations of equilibrium. But in Lami's theorem, you have to convert it. So let's do one problem. You have three concurrent forces. So I'll just draw that. Okay, three concurrent forces, which is F1 is equal to 250 Newton. F2 is not given. Okay, then you need to draw down, and F3 is equal to not given. We can draw a horizontal if you want, and with respect to horizontal, this F1 is 60 degree. With respect to horizontal, this F2 is again 30 degree. Okay, so first we will solve this problem with Lami's theorem. We need to find out F2 and F3. So we have studied, we should know what is this total. We know this is 90 degrees. So this total angle we need to find out. So so first of all, let's do for F1. F1 is this force, and opposite to that is this angle. So we need to know that this is also, say, both side 90 degree, and so that is 30 plus 90, which is 120 degree as in total. So this one is 120 degree. So let's do F1 divided by sine 120 is equal to, let's look at this F2. F2 is this, opposite angle is this. So 60 plus 90, how much is it? That will be 150. So F2 divided by sine 150 degree. And remember to have your calculator set in degrees, not in radians. So remember to have, do that. And F3 divided by this is your F3, and opposite angle is this. So you know the total is say 180. You have 90. So this should be how much? Should be 90. Okay. So this should be F3 divided by sine 90 degree. Okay, and this is your equation. You just have to solve it. So the first one, F1 is 250 divided by sine 120 is equal to F2 divided by sine 150. So what is F2? Therefore F2 is equal to 250 divided by sine 120 into sine 150. Okay, and you should the answer is, I'll write the answer here. Answer is 144.33 44.33 Newton. So this is your first answer, and you can again calculate the F3 by the same method, and you can write the value of F3. F3 is equal to 288.67 Newton. So this is how that is. These are your two values by Lami's theorem. Okay. Okay, now let's look at how this problem can be done using equations of equilibrium. So we have I have already told you, in the case of equations of equilibrium, sigma h is equal to 0, and sigma P is equal to 0. So both the summation of horizontal component as well as vertical component we will be equating to 0, so that we can find whatever is required to find. Okay. So you again have your forces. F1 we know is equal to 250. 250, sorry, Newton, not degree, so Newton. I'll just draw the horizontal, and this is F2, and this is your F3. So you need to find F3 also. This one is 30 degree, this one is 60 degree. Okay, now we need to draw the components. So let's take is as it in quadrants. So let's find the components. So this is your y, say y dash, thing like that, y axis, and x dash. Okay, so let's draw columns as I have this will avoid mistakes. Okay, so let's draw a few columns. Okay, and we'll have some serial numbers and the components written. And now let's do it. So this is your say quadrant, and this is your component x, component y. Okay, so take it 1. So let's see, for the first force is in the first quadrant, so let's draw like this. This is your force F2 is making an angle with the horizontal 30 degree. Okay, now let's have, this is F2 sign is plus, both plus, first quadrant, right? F2 cos 30 and plus F2 sin 30. So that is done. Now let's do the second one. Second one is, let's draw, it is in the second quadrant. Let's draw the resultant. So we know one is minus, x is minus, and y is plus. Okay, so plus, just to remember, so minus F1 cos 60. See, it is making an angle 60 with the horizontal, and plus F2 sin 60, and the third force F3. So let's cover it up. Okay, all right. F3 is like this. This is F3. It's in the third quadrant. So we know both are negative. So minus F3 cos 90. So cos 90 we know it is 1. Cos 0 is 1 and cos 90 is 0, sorry. And minus F3 sin 0 0, sin 90 is 1. Cos 0 is 1 and cos 90 is 0. So this term will become 0. Okay, so now let's add it up. So we have equated, so we know sigma h is equal to plus F2 cos 30 minus F1 cos 60, and this is sigma v is equal to, and you don't have the last one is cos 90. Cos 90 is 0. So sigma vertical will be plus F2 sin 30 minus F2 sin 60. So this to the minus F3 sin 90. So this much I'll just rewrite it because it's not very clear. So again I'll write it here, sigma v is equal to plus F2 sin 30 minus F2 sin 60 minus f3 sine 90. Okay, this much we can, and now we need to equate that to the h and the v to 0. So I'll do that. So that is 0 is equal to, you need to write down that 0 is equal to f2 cos 30 minus f1 cos 60, and 0 is equal to the second one, 0 is equal to f1 sine 60 plus f2 sine 30 minus f3. So cos 90 is sine 90 is 1. So that's why. So you will get two equations like that. From this we already know the value for f1. So let's take it like this. 2 say f2 cos 30 is equal to 250 cos 60. Okay, and f2 is equal to 250 cos 60 the whole divided by cos 30, which is 144.3 Newton. Okay, so you know f2, you know f1, so that we can substitute in this equation. This equation f1 and f2 will substitute and will form this. 0 is equal to f1 we know 250 sine 60 plus f2 we know 144.3 sine 30 minus f3. So f3 is equal to, if you compare it, you can find the second value also. This is f2 and f3 is equal to 288.67. Hope you understood the problem. Thank you.